Good morning, friends. This is Professor Chaubey's physics class under the heading Physics Made Simplest for G and IIE and NEET and CBSE course, that is plus 2 physics course. Last time we completed our transistor action and the common base configuration of transistor. I told you that there can be three configurations: common base, common emitter and common collector. So we have completed characteristics of transistor in common base configuration. Now I talk about the configuration of transistor under common emitter configuration. Well, common emitter configuration means, of course, emitter is common in the collector and base circuit. You see, I am showing here NPN transistor. Here this is the base, this is the collector and this is the emitter. Arrow is showing that current flowing out like this. So here, this is the, as I told you that as per rule, emitter base circuit is forward bias. So emitter circuit is forward bias, means that a base circuit. This base is the P. So P, I am applying positive potential, means the holes will go forward. So it is forward bias. And collector emitter circuit, collector circuit reverse bias. This collector negative, so I am applying positive potential here. So this will hold the electrons, negatons, and will not allow them to flow. That is the reverse bias. So this collector emitter is reverse bias, base emitter is forward bias. So, and this is the NPN transistor. Similarly, I have PNP transistor. For this, just I have to reverse the polarity, nothing else. This RC is the load resistor, where I get the output across this two terminal of the load resistor. I measure potential, that is the output. And here is the input signal, oscillator, or any signal which we want to amplify. So we are feeding the base here by the signal. The transistor is working under common emitter configuration, IE current flowing in the emitter, IC current flowing in the collector circuit. Say this is IC here, and this is a IE here, and base current here, this is the positive, so base current IB. So, sorry, this, because this is the positive, so current going like this, and this is negative. So this is the NPN. So this P is the positive potential, means forward bias, because the holes are pushed forward to move and current flows. Here it is just opposite to this. That is the current is the going in this direction. That is the emitter current, and this is the negative. This is the positive. So this is the collector current flowing here, IC, and here this is the positive. So this current flowing in the base circuit. So that is the, this is opposite to this, yeah, sure, because this is the negative. So this is coming like this. So this is the IB. So these two circuits are common emitter. Emitter is common in the base emitter base circuit and collector emitter circuit. So that is called common emitter configuration. And we apply some signal here and we get output here. That we measure delta of this BC and we measure delta of, means delta, you can say B output and B input. That we know output upon input is called the gain. So I have explained the meaning of common emitter configuration for the case of NPN transistor, also PNP transistor. Now let me have some more details of this common emitter configuration transistors. I will make a short videos. Long videos people are avoiding, they don't read, they have no time to read. So I will make short videos and just say the ratio of change in current, delta IC and delta IB. You see, the ratio of change in collector current to change in, say, base current. Because input circuit it is a change in base current and output circuit change in the collector current. This ratio is defined as we defined alpha yesterday, in last turn, alpha part coefficient. Here we define another transistor parameter, that is a beta. And beta is defined as delta of IC over delta of IB, the ratio of change of collector current to base current. And we earlier defined, now we get the relation between alpha and beta, the two parameters of a transistor as we defined. So we have beta is equal to delta IC over delta IB, and alpha is equal to delta of IC, that is the change in the collector current, divided by delta of IE. It was the emitter, that is the base, common base circuit and common emitter circuit. From we have IE equal to emitter current goes to the collector side, which is sub-collector current passes through base, so it is IE is equal to IB plus IC. We can have delta of IE is equal to delta IB plus delta IC. Well, this gives us delta IB. Delta IB, that gives us delta IB is equal to delta of IE minus delta of IC. Okay? And now substituting delta B here, delta IB here. Substitute delta IB in the, well, I can put some equation number. Say suppose this was equation number 1, suppose this was equation number 2, the two parameters. And then we can substitute delta IB in the equation 1. Here, delta IB, we put this here. So we get beta is equal to, delta IC, beta delta IC divided by delta IB. Delta IB is this, delta IE minus delta IC. Okay? Now, dividing the numerator and denominator of right hand side by delta IE, divide and multiply by delta IE here. So beta is equal to, what we do, delta IC divided by delta IC divided by delta IE. This, okay? And here delta IC, delta IE over delta, because we are dividing by delta IE, so here divide delta IE, divide by delta IE, delta IE divide by delta IE minus delta IC divide by delta IE. So this is, I think, I have just divided by delta I, so same thing in denominator. So it is no change. So just beta is equal to, what will be beta now? Delta IC over delta IE. As per definition, delta IC over delta IE is alpha. Here delta IE over delta IE means 1 minus delta IC over delta IE. Delta IC over delta IE is alpha. So beta is equal to alpha upon 1 minus alpha. Beta is equal to, this is the relation between two parameters of transistor, alpha and beta, which are ratios of the change in the output current and change in the input current. So beta is alpha over 1 minus alpha. We get this relation. This is an important relation for the transistor parameters, because we have these two parameters. This was in the first case in the common base configuration, this alpha, and here this is in the common emitter configuration. So common base configuration, common emitter configuration. So these two parameters, beta and alpha, are related by this formula. Okay? Friends, because you don't prefer long videos because you have no time to see, so I stop here and then I will make another video for the rest of the discussion of the common emitter. So thank you very much.